After Flight 6, could we be entering a new era of innovation? The answer might lie in Starship's groundbreaking metallic heat shield. Let's dive in with a quick update on the Perseverance rover and SpaceX's latest achievements. Flight 6 of SpaceX's Starship marked a significant breakthrough in reusable rocket technology, showcasing impressive progress in two-stage landings. However, the test flight also revealed critical vulnerabilities in the spacecraft's thermal protection system, TPS, particularly during reentry. These issues offered SpaceX a valuable opportunity to enhance its designs and move closer to building a fully reusable spacecraft capable of interplanetary missions. Elon Musk, highlighting serious concerns about the TPS system, pushed SpaceX to address these problems with innovative engineering, advanced materials, and improved processes. A key issue identified during the test was the deformation and discoloration of Starship S-31's surface due to extreme thermal stress. During re-entry, temperatures can soar beyond 1,500 degrees Celsius. Without adequate heat shield protection, sections of the stainless steel hull were left exposed to these damaging conditions. This issue was compounded by the removal of over 2,000 heat tiles before the test, leaving critical areas vulnerable. Additionally, the sharper re-entry angle subjected the spacecraft to more extreme aerodynamic heating than in previous flights. The thermal stress caused visible damage, with some parts of the hull deforming and others discoloring to blue and purple hues, signs of overheating and oxidation. These flaws underscored the necessity of robust thermal protection for safe and reliable operation during both descent and future interplanetary missions. Following these findings, SpaceX immediately focused on enhancing its TPS, which is vital for Starship's reusability and functionality. The TPS is composed of ceramic heat shield tiles that protect the spacecraft from the intense heat of atmospheric reentry. Over the years, these tiles have undergone numerous design iterations, each aimed at improving performance and durability. After Flight 5, SpaceX made significant advancements to the heat shield tiles on Starship by applying a new ablative layer. This coating enhances the tile's ability to withstand extreme temperatures by gradually eroding in a controlled manner, effectively absorbing and dissipating heat. Alongside this, SpaceX reinforced the attachment mechanisms of the tiles to minimize the risk of detachment during flight. These improvements were rigorously tested on Starship prototypes such as Ship 33, which marked the debut of the Starship FY2 generation. These iterations featured denser tile coverage and an optimized layout designed to eliminate gaps that could expose the spacecraft's hull to heat. The prototypes underwent extensive cryogenic pressure and stress testing at SpaceX's Starbase facility in Texas to ensure their performance under extreme conditions. Beyond the use of ceramic tiles, SpaceX is exploring advanced cooling technologies like liquid film cooling. This system involves releasing a thin layer of coolant, such as methane or water, over the spacecraft's surface during re-entry. The coolant absorbs and disperses heat, forming a protective barrier against thermal stress. While still experimental, this approach has the potential to complement or even replace ceramic heat shields in certain areas of the spacecraft. SpaceX is also revisiting operational strategies to reduce the extreme conditions experienced during re-entry. One notable adjustment is the trajectory used during descent. A gentler re-entry angle could decrease the intensity of heat exposure, potentially extending the lifespan of the heat shield. I'd like to quickly remind you to subscribe to our channel if you haven't already. We regularly upload informative SpaceX and space news videos that you won't want to miss. Be sure to turn on the notification bell so you're notified whenever we release new content. Additionally, SpaceX plans to transition from ocean landings to ground-based recoveries using the Mechazilla Tower. This shift will eliminate the rapid temperature changes caused by ocean water cooling, which can exacerbate structural fatigue. The enhancements implemented post-Flight 6 represent a significant step forward, but they are just the beginning. Starship FY2, the next-generation prototype, incorporates numerous upgrades aimed at improving reusability and performance. In addition to improved TPS tiles, V2 features a taller design, increased propellant capacity, and a revised tank configuration. These upgrades position Starship for more demanding missions, including long-duration flights to Mars. Looking further ahead, Musk has hinted at even more revolutionary TPS technologies for Starship FY3. Potential innovations include metallic heat shields, which offer greater durability than ceramic tiles, but come with the cost of increased mass. SpaceX is also exploring hybrid systems that combine metallic surfaces with liquid cooling, aiming to strike a balance between weight and thermal protection. Elon Musk has repeatedly emphasized the importance of reusability in space exploration, describing it as the key to making life multiplanetary. A reusable spacecraft not only lowers the cost of spaceflight, but also enables faster turnaround between missions. Musk has called the development of a fully reusable heat shield one of Starship's greatest engineering challenges, underscoring its critical role in achieving SpaceX's ambitious goals. Musk recently highlighted these efforts on social media, stating that the latest heat shield upgrades have performed exceptionally well in tests and represent a significant leap forward. He also expressed optimism about the new TPS's ability to withstand the rigors of Mars missions, where re-entry conditions will be even more extreme than those on Earth. SpaceX's iterative approach to engineering, test, learn, improve, has been the cornerstone of its success. The lessons learned from Flight 6 and subsequent upgrades to the TPS system demonstrate the company's commitment to continuous innovation. With Flight 7 on the horizon, SpaceX is poised to validate these improvements and further refine Starship's design. In the coming months, SpaceX plans to conduct additional flight tests, gradually increasing the complexity of missions. These tests will focus not only on the heat shield, but also on other critical systems, including propulsion, guidance, and landing mechanisms. Meanwhile, Perseverance continues its exploration along the rim of Jezero crater, with recent travels bringing it to Pico Turquino. This approximately 200-meter-long, 656 feet, stretch of exposed rock offers a unique opportunity to study ancient geological processes, some of which may predate or be connected to the impact that created the crater. Over the past weeks, the rover has been investigating various outcropping ridges during its climb, aiming to better understand the composition and structure of these formations. Last week, Perseverance traveled parallel to Pico Turquino, maintaining a distance of about 70 meters, 230 feet, to the south. Over the weekend, the mission team executed a careful maneuver to bring the rover closer to the southwestern edge of the ridge. Before this approach, the team dedicated 2 sols to detailed remote sensing using Mastcom-Z and SuperCam. They examined the local regolith and captured long-distance images of a steep slope and a small 20-meter, 66 feet, crater located northwest of the rover. The subsequent 107-meter, 351 feet, drive on Sol 1332 positioned Perseverance perfectly for the next phase of its mission. Now positioned near Pico Turquino, the Perseverance rover is gearing up for close analysis of rock outcrops, including abrasion activities to examine exposed material in detail. Once its work at Pico Turquino is complete, the rover will head to its next destination, Witch Hazel Hill. Orbital data suggests this area may contain layered, light-toned bedrock that could provide valuable insights into Mars's ancient climate. On its journey, Perseverance will traverse Lookout Hill, a vantage point offering stunning views of Jezero crater and its surrounding terrain, along with a glimpse of the distant landscape to the west. Thanks for tuning in to today's episode. Don't forget to subscribe and give us a thumbs up if you enjoyed it. Stay tuned for another exciting video tomorrow.